This conference will now be recorded.
Hello, everybody. Welcome to the Satellite Book Club seminar series. This is session number 40. I'm Jordan Girth with the National Weather Service Office of Observations. Thank you for joining us. I hope you're staying well. I hope you're enjoying a little bit of spring weather. It's a beautiful day here on the East Coast and in other parts of the country. But if you're in Colorado, you're looking forward to some snow, I guess. In any case, today's presentation is communicating tropical cyclone hazards with satellite data. I'm glad to have Melissa Huffman, a Warning Coordination Meteorologist at the Corpus Christi Weather Forecast Office, joining us. And our facilitator is Mike Savish, the Science and Operations Officer in Medford, Oregon. Just a few reminders before we get started that this session is being recorded, so feel free to pass along a link to your colleagues that might be unable to join us today. We have an opportunity for Q&A after the presentation. So please post your questions in the chat room and we will field them in the order they were asked. We're also looking for future presenters. So if you have an application you'd like to share with your colleagues, please get in touch with us. We'd love to have you. And if you're looking for training materials, the training team can point you to materials that may be unavailable, or you might give them an idea of something they need to develop. Please contact Brian Mata, the Office of the Chief Learning Officer, for information or questions regarding that. I would just like to make an introduction of a new member to our satellite team here at the Weather Service representing the Ocean Prediction Center. Javier Alfredo Villegas Bravo is joining us. We're glad to have his expertise, and you can see a little bit about his background there. He's replacing Michael Fulmer to inform the satellite community on what forecasters want in products and tools. So Javier, thank you so much, and we're looking forward to working with you moving forward. I'd also like to thank our Tower S team, Kashad Bowman, Lee Byerly, the Office of the Chief Learning Officer, GOZAR, and the GPSS program for sponsoring the Satellite Book Club. And thank you to all of you for being with us. Looks like another good number of attendees today. Without further ado, I'd like to formally introduce Melissa Huffman, the Warning Coordination Meteorologist at the Corpus Christi office. Prior to serving South Texas, she worked for the Austin, San Antonio, Texas, Houston, Galveston, Texas, and Midland, Odessa, Texas weather forecast offices. So a great tour of Texas offices. Maybe she can tell us what her favorite one is. Melissa has a Bachelor of Science degree from University of Nebraska-Lincoln and Meteorology, and a Master of Public Administration degree with a specialization in emergency management from the University of North Texas. Melissa, welcome to the Satellite Book Club.
Thank you so much, Jordan. I don't think I will be speaking to which is my favorite office because I have enjoyed all of them so much, but they definitely have given me some really exciting experiences, particularly the Houston and Corpus offices. Today's talk is going to be about how satellite data evolves throughout the course of a tropical cyclone, how its use within a weather forecast office's operations changes, and what we'll be looking at particularly is Hurricane Harvey. Now, like you heard with Jordan's introduction, I have been in several offices around Texas. I'm currently the WCM of the Corpus Christi Weather Forecast Office, but a few years ago, I was in the Houston Galveston office when Hurricane Harvey occurred. So this presentation is going to try to show two offices' perspectives around Harvey. Now, I realize not everyone is a Texas fanatic like I am, so this may be an event that you're not terribly familiar with. So I just kind of want to walk through what Hurricane Harvey was and give you a little bit of a timeline. And that's pretty much how we're going to structure this presentation, is looking at a timeline of Harvey and the satellite data that was used within that. So just to get everyone on the same page, Harvey formed from a tropical wave crossing into the Caribbean in the middle of August in 2017, quickly became a tropical storm and then weakened as it encountered an environment of higher shear, and then really continued to propagate westward across the Caribbean towards the Yucatan. Now, once Harvey crossed into the western Gulf of Mexico, developed into a tropical storm again, and then strengthened very quickly, becoming a hurricane and then a major hurricane right before landfall. Now, Harvey made landfall as a Category 4 hurricane. It was the first major hurricane to make landfall in Texas since 1983's Hurricane Alicia. And Harvey moved inland, quickly weakened to a tropical storm, but stayed inland for about 2 days before coming back out into the northwest Gulf of Mexico. So you can see in this inset image here, Harvey's path inland, coming back out across Matagorda Bay, and then moving up towards southern Louisiana. So very long effects within Texas with Harvey's slow ascent up the Texas coast. This is a radar loop of Harvey as it's approaching the middle Texas coast. So Harvey made landfall near Rockport, Texas, which is just to the northeast of Corpus Christi. So you can see Harvey moving inland here. This is roughly August 25th, which was the day Harvey made landfall, continues to push inland, making its way all the way up into south central Texas, again, spending about 2 days inland there. And if you could take your attention off to the far right side of this radar image, you'll begin to see rain bands developing and then approach the Houston metro area. So very populated region that was experiencing just these repeated rain bands, very long duration rain event, very heavy rain. So the middle Texas coast dealing with a wind and surge threat from Harvey. And then as you shift farther up the Texas coast, that transitioned more to a tornado and heavy rain flash flood threat. So let's talk about some of the satellite information that was used to communicate Harvey and get our partners ready. When you're in a coastal office, one of the biggest things you have to do in advance of a tropical cyclone is just to convince people that the threat is there. Threat confirmation is very big, and it's that first trigger to get people to recognize that decisions have to be made. Very important decisions relating to evacuation, movement of resources, and it all begins with getting people to believe that there is actually something there. So this is an excerpt from one of the first briefings that the Corpus Christi office issued as it related to Harvey. So this is Harvey crossing the Yucatan Peninsula. There's a GOES East image. At this point in time, this was actually GOES 13. I know I talked about GOES 16 in my description for this. We were in the transition period with moving from GOES 13 to GOES 16 for GOES East during Harvey. In IR image shown here, really just to show that, hey, it's disorganized, but there is something out there. There is something that you need to be paying attention to. Low confidence situation at this point in time, but there is a hazard on the horizon for folks in Texas. As we continue to step through our timeline, so that first briefing was issued August 22nd. What I've gone through is pulled some of the descriptions of the satellite analysis from forecast discussions from the National Hurricane Center. And you can see as we even go into August 23rd, Harvey's still not organized well at the moment, but then later discussions really begin to talk about the environment that Harvey will be moving into. So one of the discussions really pointed out the role of the loop current. So this is a warm water current that flows effectively from the Caribbean into the eastern Gulf of Mexico and then makes its way back into the Atlantic through the Straits of Florida. Noted that a warm water eddy had broken off of this, and this is concerning because these can help contribute to intensification of tropical cyclones. So that was an environmental feature evident on satellite that was incredibly concerning as Harvey was moving off of the Yucatan and approaching the Texas coast. We were also seeing that the environmental shear was decreasing. So these low shear environments are also very favorable for additional storm intensification. So Harvey could end up in a low shear environment, which is also not good when you're looking at an approaching tropical cyclone for intensity purposes. So by the time we get to August 24th, these discussions are noting that the current intensity may have to be adjusted upward with Harvey. So Harvey, you have this, what initially started out as a tropical wave, again, quickly strengthening, approaching that tropical storm status, becoming a hurricane, and then there are concerns for this major hurricane or Category 3 or greater intensity. So this is a look at the GOES low-level water vapor imagery. Within the discussion that was issued during the morning hours the day before landfall on August 24th, you can see the Hurricane Center noting that the intensity forecast has become quite concerning. They're noting expanding outflow, indicating that Harvey is in a low shear environment, and this again just contributing to that concern for Harvey's intensification. One of the things when you're briefing emergency managers during this event is you're really trying to give them confidence in your forecast, and you're trying to give them a sense of what may happen. One of the things that we really try to prep emergency managers to do is to prep for one category higher when you're thinking about what a landfalling system may do in your area. And so all the information that we can give them to give them confidence in intensity is important. Why is that important? Well, we have less skill with intensity forecasts than track forecasts. So you can see some fairly dramatic shifts in forecast intensity. One of the concerns with Harvey, given the low shear environment that it was moving into with that warm water eddy, was the concern for rapid intensification. So when I'm talking about with rapid intensification, I'm talking about an increase of sustained winds of at least 30 knots in a 24-hour period. And one of the ways that you can look for maybe anticipating this rapid intensification event would be looking at lightning trends. So I have here just an excerpt from some research from Demaria, basically showing that looking at the outer rain bands of a tropical cyclone, trends in lightning activity and really lightning density can maybe give you a little bit of lead time for when a rapid intensification event may be occurring for a tropical cyclone. So taking a look at some of the GLM data that was available during Harvey. In fact, I was talking with the meteorologist in charge for our office, who's actually my predecessor for the position that I have now. And he was mentioning how they were watching the GLM data during this event and seeing, that this was becoming a very serious situation for the Middle Texas coast. So this is just a look at one of the rapid intensification events that occurred for Harvey. You have some of the NOAA Hurricane Hunter aircraft reconnaissance data shown on the left-hand side of your screen. And I just want to draw attention to this 10-hour period here where you had some inbound winds picked up from the Hurricane Hunter recon team, increased by almost 50 knots within a 10-hour period. So very dramatic change in intensity. And you can see the increase in lightning activity as well within the outer rain bands. Now, keeping in mind that I'm showing kind of two offices perspectives here. For the Corpus office, this is concerning because of the change in intensity that we've been talking about for the past few moments. But for the Houston office, as these outer rain bands begin to come on shore, this is also raising concerns for, what does this mean for storm interrogation? And the Houston office was under a tornado watch for probably a good 4 days while Harvey was ongoing. So this is, are we going to need to be stepping up our operations for working a significant tornado event for our region? Now, Harvey continued to move inland. So Harvey made landfall again the night of August 25th. It was a Friday night. Made landfall at Rockport, Texas. So this is very close to where landfall actually occurred. And this is just showing you some of the damage that Harvey produced. But again, once Harvey moved inland, it didn't stop producing hazards. It didn't stop causing impacts. And as Harvey was inland the night of the 25th and then into the day of the 26th, the threat really began to shift up into the Houston area. One of the big challenges, though, that office faced is looking at satellite imagery there, you actually see some breaks in the clouds. So I've got a Sierra geocolor image on the left and then some cloud geometric thickness on the right there to give you an idea that it wasn't a very dense cloud canopy over the Houston-Galveston metro during the day on the 26th. The Houston office leading up to this had been briefing about a significant heavy rainfall event unfolding for the region, but people within the Houston-Galveston metro on this day were actually seeing breaks in the clouds. They were seeing the sun. And so this was giving this false impression that the event was over, that this rain wasn't going to materialize, which was a significant messaging challenge. In talking with Dan Riley, who was the Warning Coordination Meteorologist for the Houston office and still is, that was something that they were really having to hit on their webinars that afternoon to let people know the event is not over for us. Harvey is still going to cause a catastrophic rainfall event. This is a look at our shift change the night before the first round of significant rain bands begin to develop over the Houston-Galveston area. I just want to draw attention. I'm sitting on the far right-hand side here. I'm briefing my incoming shift relief. He's a forecaster named Chuck, an amazing forecaster in the Houston Galveston office. But what we were doing during this time is we were watching infrared satellite, and we're seeing these incredible cloud tops beginning to develop just west of the Interstate 45 corridor, which is a very populated corridor across Houston-Galveston. And so we see this deepening convection in the rain bands. We're seeing cloud top temperatures colder than -90. And this is an incredibly concerning thing. And I distinctly remember Chuck looking at me and going, we're going to be issuing flash flood emergencies tonight. Now, keep in mind, Houston is a very savvy office when it comes to flash flooding. And so IR is incorporated regularly into any kind of interrogation within a flash flood or heavy rain event. And this was one of the things that initially at shift change, everyone was beginning to mentally prepare for a very long night. By the time all was said and done, Harvey had left a significant rainfall footprint across not just Houston-Galveston, not just Corpus Christi, but across a good portion of the southern half of Texas. So a wide swath of 20 to 40 inches across portions of southeast Texas, with higher amounts in the 40 to 60 inch range. And this is over the entire event duration of Harvey. So this is looking at the August 25th to September 4th period. Again, keep in mind this was a multi-day event, but rain extended all the way up into the Austin and San Antonio areas too. So again, lots of water falling onto the ground. But once that water falls and hits the ground, it has to go somewhere. And all of the rivers in this part of Texas drain into the Gulf of Mexico. So as water from Harvey worked its way into that main stem river system, flooding began to occur in areas where it wasn't expected to begin occurring. So what you're looking at here on this image is a map from one of the emergency managers in Wharton County, which is about halfway in between Houston and San Antonio. And that red circled area is an area of his county that was flooding from the Colorado River, which is just kind of this gray squiggle in the middle of his map here. But this area was flooding, and it was not supposed to be flooding, which left the service hydrologist at the Houston-Galveston office, the hydrologist at the West Gulf River Forecast Center, asking, where is this water coming from? As they began to take a closer look at it, they realized that multiple basins were experiencing excessive overflow. So this was allowing water to move from one river basin to another. And so I have here just a rough drawing of the river basins across Southeast Texas. So essentially we were having water moving from one of these areas into another area. And you can actually pick up the flooding that was occurring on satellite. So this is a look at the day snow fog RGB image. And so really that veggie band helping to contribute to the depiction of floodwaters shown here. So you can see basically all of the black on this image are areas that are flooding across Southeast Texas. And so you have certain river systems highlighted. The two rivers of concern really for this interbasin transfer are the Colorado River and the San Bernard River. Now, being able to confirm that this interbasin transfer was occurring allowed the forecasters at the West Gulf River Forecast Center to really do some fantastic decision support and capture that this was happening using GOES imagery. And I should note is that Harvey was really the first hurricane that we were able to use GOES 16 imagery with, and it was really, you know, giving us our bang for our buck here with what it was showing. But they were able to take a geocolor image to show water coming in from the Colorado. And keep in mind, the Colorado has got a lot of debris coming into it. You've got you basically see this muddy slug of water moving into the San Bernard. San Bernard, much more vegetation around it, so kind of holding back some of the sediments that would make its way into that river. So you don't see it quite as pronounced on this geocolor image. But the Colorado, you see a very quick change in vegetation and land cover as you move west of Houston. And so you can see much more sediment getting into the river there. But West Gulf River Forecast Center put together this graphic to really highlight, look, the changes that you're seeing in the latest river forecast are reflecting this information. There's two hydrographs shown on this screen to basically show how water was behaving at two gauged locations. So the dashed lines on here represent what that original forecast was, what the expectation was for the river at these locations to do, but incorporating the confirmation of that interbasin transfer and latest satellite imagery allowed them to update those forecasts to really help emergency managers and decision makers move the resources and provide the assistance that was needed. So Harvey was a much, much, much bigger event than what can be captured in 15 minutes, but I thought there were some really neat applications of satellite from this. So I would encourage you to reach out to my office, the Corpus office, reach out to the Houston office, West Gulf River Forecast Center, if you have additional questions about their usage. But in terms of data needs, because I think we may have some researchers or developers on this call, better segregation of water from land and satellite imagery is needed, particularly within these long duration flood events. And then I think, kind of a standing request from forecasters would be improved satellite precipitation estimates over data sparse areas, better tropical rain event estimation to help with warm rain processes, higher resolution satellite products. I don't think anyone is going to disagree with me that you always want a clear picture. But something that I would love to put into people's minds is extending GOES mesosector request for areas undergoing recovery. So a lot of times I think we're really proactive with making these requests before an event, during an event, and then sometimes we don't necessarily think about the applications of satellite data following an event. So that would absolutely be something that I would just like to put in the back of people's minds is don't hesitate to make those requests to help support your partners. I would like to acknowledge a few people that I bugged to help me with this presentation. Katie Landry-Guyton, the Senior Service Hydrologist with the Houston Galveston office, Dan Riley, the WCM in Houston, Derek Giardino, a Senior Hydrologist at the West Gulf River Forecast Center, my boss, John Metz, MIC for the Corpus Christi office, and Lance Wood, the Science and Operations Officer at Houston Galveston. So that, again, was just Harvey in a nutshell. Much more went on. If you have any additional questions following our discussion today, don't hesitate to reach out to me at melissa.huffman@noaa.gov. But I want to thank you all for allowing me to speak about this topic this morning. So thank you.
Okay, wow, thank you, Melissa. What an interesting presentation. It really shows the magnitude of the events we have to deal with on occasion. And very interesting to hear how you integrated the GOES imagery there. At this point, let me encourage attendees to stay on for discussion here and to complete the feedback survey that will be posted in the forum here very shortly. Before we get going on addressing some Q&A, let me mention that a week from today, on Thursday, March 18th at noon Eastern Time, Trenton Davis, meteorologist from the Philadelphia, Pennsylvania WFO, will discuss the use of lightning and the NOAA SIMS Prob Severe model in tornado detection over the mid-Atlantic. I'd also like to encourage attendees to contact the Tower S team, Lee Byerly, Kashad Bauman, for questions about the SBC or for configuration of satellite products. And look for more information to follow in an email from the Tower S team. So let's get right into the discussion here. I'd like to remind attendees you can submit questions in the chat box or raise your hand and we'll try to address you with a verbal question if you'd like to do it that way. So Melissa, if you're ready, we've got a few questions here that have been coming in and we'll go ahead and get we'll go ahead and get started.
Absolutely.
Pardon me?
Absolutely, I'm ready.
Oh, good. Mark DeMaria poses a question. Did you use any lightning graphics in the real-time DSS briefings for Harvey?
So that's a great question. and I should clarify that my role during Harvey, I was a general forecaster, so I was primarily working radar and hydrology desk. In terms of use of lightning graphics for DSS briefings during Harvey, that would actually be better questions for John Metz and Dan Riley in terms of what they were using. So I am not sure, to be honest, what they were using in some of their briefings.
Okay, yeah, thanks. That was there's a lot more work going on with the lightning data now, so I was just curious. That was pretty early on, so it was interesting to see that you showed that as one of the things that possibly could be used.
Okay, thank you for that answer. Another question from Robert Bright. Partners often ask about our confidence, but that's a tough thing to define as it's mainly subjective and that can vary between forecasters and for different hazards. We try to utilize the probability forecast information, but that can also be challenging and or misleading. Do you have any recommendations on how to best handle that?
Confidence is a big thing. And one of the things that I'm finding, particularly from, the past hurricane season, is they really want to know it, but unless you standardize it and unless you explain to them what's going into that, I'm not sure that they necessarily know what to do with that information. So I think before you go into any kind of situation where you're briefing confidence, you as the forecaster or the briefer need to be able to explain what you're using in that confidence. So are you briefing specifically on whether or not that hazard's occurring? Are you briefing on when it's occurring? Are you briefing on a combination of things? And regardless of what that is, you then have to set the expectation that that is going to be how that confidence is communicated through the duration of the event, because you're absolutely right. It can change from forecaster to forecaster. So I think when you're talking about confidence, it's something that you have to set the expectation with early, and you have to make sure that within your office or unit, whatever is briefing that information, that they're all using those same requirements. So this goes back to kind of the pre-season coordination and planning that you do. It's really difficult to just try to implement use of confidence on the fly within a major event like this.
Yeah, Melissa, you mentioned earlier the word threat confirmation, and using the GOES imagery, I imagine, has certainly improved the ability for your offices in that coastal environment down there to do that. Some of the imagery from GOES, especially the GEO and others, is pretty impressive and really gives a visual confirmation for folks. Have you found that you use the GOES imagery more in threat confirmation? And of course, that can lead to conveying confidence in the public's eyes, I suppose.
Yes, so in any tropical briefing, we always have at least one GOES satellite image included in there. And that's just because it really sets the tone. The emergency managers, at least within South Texas, actually do compare briefings. So they look to see how confidence changes between briefings, but they also look to see how the storm changes, because I will get questions, hey, I noticed that it's in this different location, or the track has shifted slightly. What's going on with that? But using satellite information in a tropical briefing is incredibly important, because again, you're giving something then tangible to focus on. A picture is worth 1,000 words, and this is letting them know, yes, that this hazard is there, and it is something that you still have to pay attention to.
Okay, thank you. Scott Lindstrom posted a question here. He said you had some imagery from AWIPS and some not. How much of a problem is that you have to go elsewhere, for example, outside of AWIPS for imagery?
So part of the problem that I ran into with this presentation is I just did not have some of the archived images from AWIPS, which is why I was looking outside of AWIPS. One of the things, though, that I do think is interesting is within our COVID environment and teleworking, sometimes we are having to go outside of AWIPS to get satellite imagery because we're what we're doing from home. So it's only a problem in the sense of maybe having a repository, or maybe just knowing where all of these different satellite images are. I think once you get into a routine, though, and I think we're getting to the point now in our telework environment where we've got a good handle on where these resources are available. But I think that's just the biggest thing is knowing what all is out there, because there is so much information, and just having a quick reference to it, I think, would be really helpful.
And we had a comment here: to observe flooding from satellite, did you also employ the VIIRS flood aerial extent product at the 375 meter resolution? That's accessible in AWIPS by LDM and online. There's a link that will be posted for that, or I think Jarrell did post that already in the chat.
So when I was talking to the West Gulf River Forecast Center about their operations about this, I don't believe that the VIIRS flood information was available within this. So I can't really say that that was used because, again, I don't think that it was available, but it is good to know about its accessibility. And I see the link there, so I appreciate you posting that, Jarrell.
Okay, we've got a few other questions here, and then we're going to have Jordan come in with a few questions. So let me just touch on one or two others that I had. You mentioned how the imagery, and you mentioned the other inputs that you were looking at allowed you to observe the storm intensification as this tropical system crossed the Yucatan and approached the Texas coast. That seemed to be quite a critical period in preparing for that storm as it reached that major hurricane intensity as it hit the Texas coast. I think you showed some visible and some GLM data during that period. I imagine there's a number of other inputs that you looked at. Can you touch on a little bit how that GLM data perhaps contributed to your situational awareness during that critical period?
So I think, right off the bat, seeing the increase in activity in the GLM data is, confirmation of, all the rapid intensification that the models were indicating was actually occurring. This was the first season, I believe, that we really had the HWRF and the HMON operational, and some of those rapid intensification indicators within those models really hitting at Harvey taking off in intensity. And so then to get that confirmation, almost real time of, yeah, it is happening. I think that really just kind of helps with changing the wording. If I had had more, I would have shown some of the later briefings that the Corpus office was putting out, but it was very, very strong language in terms of what kind of threat Harvey was going to be for the coast. I mean, you see kind of almost a complete change in the posture, whereas the initial briefings were, well, it's low confidence, but it's something to keep watching, to using red text on slides, which almost always pops out and lets you know, hey, you really have to be paying attention to this situation. So for the Corpus office, really just kind of confirmation, what you're briefing on, it's happening, and you're getting ready to go into what is going to be, a catastrophic event for portions of your region. From the Houston office, from my perspective as a forecaster at that point in time, that Friday afternoon, because we had been watching the scope all day, we'd been watching radar all day and hadn't really seen too much activity in terms of the rain bands that Friday morning. But then you begin to see the lightning activity, take up, and then we actually began to have many supercells embedded within the rain bands begin to come ashore. And so that was really, that Friday afternoon was kind of the beginning of the tornado event for that region. So the lightning data in that sense kind of let you know something has changed. Something has changed, and the event posture, the event tempo is also about to change with that.
Okay, all right, thank you. In your recollection, in which part of Harvey's timeline did you find the satellite information most important for messaging?
So I think it was incredibly important throughout the entire event, but I think it was really helpful following the event. One of the biggest questions that you get, with any disaster is, how bad is it, or which areas were most affected? And so I think that you're able to utilize satellite information to really kind of provide that quick, this is what's changed. So we only talked about the utility and the application within the river forecast sphere. But you did also have, catastrophic wind damage that occurred farther down the coast. You had significant storm surge damage that occurred. So I think that within the recovery section, that really helps focus attention on these are the areas that we really have to address first. So in my mind, it was really kind of that, storm dissipation, post-Harvey timeframe in which the satellite information was very helpful for decision makers, and then also making sure forecasters were aware there are still incredible sensitivities to the forecast going forward because of the ongoing hazards that we can see on satellite.
Yeah, I think you touched on some of that when you showed the day snow. I think it was the day snow fog imagery and also some geocolor imagery post-event where you could really bring out details. I imagine those RGB pictures really added a new element to sort of post-storm briefing and DSS.
Yes, and the good news with these RGB images is they're, very intuitive to interpret. So you can quickly show it to an emergency manager, and it's easy for them to understand this is what I'm looking at within this image. It doesn't require a lot of extra interpretation.
Well, I really appreciated seeing everything you have to offer. Let me turn things over now to Jordan. I think he has some things to say.
Yeah, thanks. I just have a few more questions for you before we wrap up. Thank you so much, Melissa, for your presentation, your time putting this together. So one of the things that you mentioned on your data needs slide, you talked about satellite precipitation estimates, and you've also mentioned that you were using radar. So I'm a little curious about whether you think that you can get better precipitation estimates compared to radar, or you're just mainly interested in that for a full picture of the storm because you might have less than ideal radar coverage over the ocean.
It's really for that full picture. You have in portions of Texas a really dense, rain gauge observation network, which helps provide that ground truth. But then you also have portions of Texas where you don't have that dense gauging network, and you also have limited radar coverage. So the more information you can provide to get that whole picture of how much rain has fallen, I think is incredibly helpful. But there's some regions of Texas that I think are doing much better in the terms of that right now with current data than other parts are.
Great, thanks for clarifying that. And my next question is, we've heard in previous presentations at the Satellite Book Club about the use of synthetic aperture radar SAR imagery. GOES is certainly good in many ways and is good for a quick image, but it doesn't provide the highest resolution image. So my first question is, have you heard of and do you use SAR? Maybe that's two questions. And then my third question is, you talk about higher resolution satellite products. What resolution do you want to know that the flooding is occurring?
So with respect to the SAR data, I don't currently use that. So that is definitely an area that I need more exposure in, to be perfectly honest. In terms of the resolution, I think that, with the amount of rain and the volume that we saw during Harvey, you were able to pick out the flooding very easily, but you can certainly have flood events that are not necessarily captured. And so I don't know if I have a specific resolution in mind, but just something to maybe capture some smaller scale flood events as opposed to something, with Harvey when you're contending with, 40 to 60 inches of rain working across, parts of a river basin.
And then my final question is, we have a lot of monitoring on rivers, streams in that area. I think, is it the San Jacinto? Is that how you pronounce it there, or Jacinto River near Houston? There's ground truth there, but that's not necessarily reflected on what's going on with urban flooding in the city. Is there ways to approximate your urban flooding from what's going on in nearby rivers and streams that are in that same basin?
Yeah, so you have to keep in mind Houston has a very pronounced flood control system and a very strong flood control district. So they do a lot to work with kind of distinguishing between those two events in cooperation with the Houston office and West Gulf River Forecast Center. So when you're talking about flooding on the San Jacinto versus flooding within the San Jacinto Basin, it gets a little tricky, but those three entities, the RFC, the Houston Galveston office, and the Harris County Flood Control District, do work to make to distinguish between those types of events, and then along with that, message that to the population subject to it, because that San Jacinto River Basin pretty much covers all of Harris County, which is where most of the population is within that forecast area.
Okay, thank you so much. That's very helpful, and I really appreciated your presentation. Mike, are you seeing any other questions that we need to address? Looks like it's just about time to wrap up.
Yeah, I think you can wrap up, Jordan.
Okay, sounds good. Well, Melissa, thank you so much for being with us. This is a really informative presentation, and I'm really going to take back the satellite needs that you had there on one of your final slides. And Mike, thanks to you for moderating today. I really appreciate that. I think we had a very good discussion. Everybody, to our audience, thank you for participating. I hope you're staying well. I hope you'll join us again for the Satellite Book Club next week. We've got Trenton Davis, meteorologist in Philadelphia, who's going to be discussing the Prob Severe model for tornado detection in the Mid-Atlantic. And with that, hope everybody stays well, and we'll see you next week.